So in this video, we're going to be talking about type 1 and type 2 error that can occur when you are doing null hypothesis testing. And to remind you what null hypothesis testing is, remember the whole goal of conducting our statistical tests, right? Our whole goal of conducting our statistical tests is to see whether we can find the signal in the noise. Well, when we're talking about a null hypothesis, what we are saying is that there is no signal in the noise. So a null hypothesis means that there is no relationship between variables. There is no effect of one variable on another. There's no difference between means. So there is no signal in that noise. So in our studies, we're making a decision about the null hypothesis. We're either deciding to reject the null hypothesis and say, no, I reject the idea that there is no signal. Instead, there is one. There is an effect, there is a relationship. Or we can fail to reject the null hypothesis and say, well, we can't reject the idea that there's no signal out there, so that's an outcome as well. Now, that decision about what we do with our null hypothesis based on our test statistic either reflects what's going on in the real world or does not. And that's where we can make an error. So let's flesh out the possibilities here. All right, so let's flesh out the possibilities. In a nice 2x2 table. So on the one hand, we said one of our decisions has to do with what you do with the null hypothesis based on your test statistic. Oop, that's not nice. And we said you could either reject the null hypothesis or you can fail to reject it. And then you have the state of the world. What is the state of the null hypothesis in the real world? Or in the population. So one option is that the null hypothesis is false. And the other option is that the null hypothesis is true. So let's talk about what this means in terms of the signal, if the signal is there or not. Because when you're dealing with the null hypothesis and you're saying that there's no signal, then you want to reject that, it gets really confusing because it's a double negative, okay? So let's be clear about when we're saying there is a signal and when there isn't. So if the state of the null hypothesis in the real world is that HO is false, the null hypothesis is false, the idea that no signal exists is false, then we're saying, hey, there's a signal. There's a relationship, there's an effect, there's a difference, depending on your study. If HO is true, we're saying there's no signal, or at least no detectable signal. Individuals who have a beef with null hypothesis significance testing, and rightly so, will say, well, you know what, there's never no signal. It might be very, very small or negligible, but there's never no signal. So we're not going to split that hair in this particular video, but realize that. Now, our decision could be to reject the null hypothesis, in which case we're saying we reject the idea that there is no signal, therefore there is signal. Our test statistic is large enough that we think it's not determined by chance, and therefore we're rejecting the null hypothesis. You can also fail to reject that null hypothesis, and then we're saying, you know what? There's no signal. We can't reject the idea that there is no signal, therefore there is no signal. Okay, so let's work through these decisions. So if we say that there's a signal based on our test statistic, and in reality there is a signal, great, we've made a correct decision. Nice. Now, if we say there is a signal and in the real world there is no signal, we've got a problem. We've made an error. And this is called a type 1 error. A type 1 error arises when you say there's a signal based on your test statistic and really out there in the real world there isn't. This is a type of error that occurs due to statistical chance. Just by luck, you happen to get a really high test statistic that led you to the conclusion to reject the null hypothesis, but it was just dumb luck that you got a test statistic that high this time in this study. This is why replication in science is so important. Now, the other option is that there is a signal in the real world, but you can't detect it in your study, and that's called a type 2 error. Now, a type 2 error might be considered even more serious than a type 1 error given a certain situation because you weren't able to detect the signal in the noise. The noise was so loud that your study, your instrument, your procedure could not find it. And that can have some serious implications, as we'll talk about a little later. And the final option is that there's no signal in the real world or in the population, and we conclude in our study our test statistic is too small to reject the null hypothesis. Therefore, we're saying that there is no signal or such a small signal as to be considered negligible. All right, so let's say in the real world our null hypothesis is that there is no blizzard coming within the next 24 hours. Now, you can use this example with any adverse weather effect. I'm from New England, so blizzards are kind of common, so we're using blizzards. So what are the possibilities? Okay, well, our meteorologist friends could say, okay, you know what? According to all of our predictive models and according to our instruments, we're going to reject the null hypothesis that there is no blizzard. In other words, there is a blizzard coming. And in the real world, there is a blizzard coming. Okay, so the null hypothesis is false in the real world, there really is a blizzard coming, and the meteorologist makes the correct prediction. Well done, meteorologist. Not so happy for us, but at least the decision is correct, so we're happy. Okay, so the blizzard's coming, and the meteorologist got it right. So you have another option, and the meteorologist could say, there's a blizzard coming, rejecting null hypothesis because their predictive models are so strong, or the test statistic in their models is so high that it's unlikely that it would be due to chance. But in the real world, a blizzard really isn't coming. Blizzard never materializes. That's a type 1 error, and it's kind of annoying. But, an incorrect decision, but not so much harm done unless, you're a little kid and you really, really want your snow day, or you're a college student and you really, really want your snow day. Now, consider this. What if the instruments were too insensitive to detect a real blizzard coming? So the meteorologist says, no blizzard. Okay? They fail to reject the null hypothesis. There is no blizzard coming. But in actuality, there is. That's a type 2 error. The instruments were insensitive enough to pick up what's going on in the real world. Now, this is really bad, right? So here there actually is a blizzard coming, and you don't think there is one coming. So you haven't gone to get your milk and your eggs and your extra water and your bread. You're caught unprepared. So type 2 error can be pretty problematic. And then you have the final option where the meteorologist says, sorry kids, no blizzard, and despite, putting your pajamas on backwards, spinning around 3 times and spitting in the toilet, there really is no blizzard. So the meteorologist is right, but kids are upset. So no blizzard here. Now, is it ever the case that a type 1 error is pretty serious? Yes, it is. So can you imagine a study where they're doing a clinical drug trial, and this particular drug that's being tested has a lot of side effects, okay? and you conclude on the basis of your test statistic that this drug works, but you've made a type 1 error. It's just chance that you happen to get that large test statistic this time in this study.